Hello friends and good evening. Welcome to our channel Genius Structures. I am your host Dr. Sumant Kulkarni. Today I am going to explain you the concept of sway type of portal frames which we often encounter in real life problems. And students always get confused in how to exactly identify whether a given frame is a sway type of portal frame or not, or whether given frame is non-sway type of portal frame. So practically how we can identify a given type of frame as a sway type of frame. So when we are going to say sway, it is actually there is some horizontal loading acting on the building. It means we already know there are different types of loadings acting on any type of building, which are dead load, live load, earthquake load, wind load, and so on. Correct? So among all these types of loads, wind load is a predominant load in case of buildings. But again, there is some difference. If a building is low-rise building or medium-rise building, low-rise I mean to say G+4 ground story plus 4 number of floors above ground story, or G+10, then wind load is not predominant. Then live load and gravity load is usually predominant. Okay, that is dead load and live load. So which is vertically downward. Gravity load I mean to say vertically downward load. But as you go on increasing the number of floors of a building, if you say going for the analysis of a G+15 story building, then in these types of buildings, obviously earthquake load and wind load will be predominant. And usually we see that in case of wind loads, it is in horizontal direction. I mean to say, if this is your load, this is your building, so along perpendicular direction of this line of action of the building or axis of the building, the horizontal load is acting, and it is going to act perpendicular to this axis of the building. So this building will be swaying in any of the directions. So this is how the wind load will be predominant, and this is how we are going to identify a given building is a sway type of building or not. So when we are saying building, we have to obviously come to the analysis of frames. So now we shall see the frame, whether it is a sway type of frame or non-sway type of portal frame. So now let us see what are the different possibilities for a frame to qualify as a sway type of portal frame. If you see here on the board, I have drawn some of the portal frame diagrams, and also I have written some descriptions. Let us start with number 1, different end conditions of columns. For this we have to refer to diagram 1, this one. Here if you see, this is one column of the frame, this is another column of the same frame, and if you see bottom ends of the columns, one end is fixed and another is hinge type of support. So for a single base single story frame, if one column is with fixed end and another column is with different type of support, for example hinge, then this particular frame we are going to say it will be a sway type of frame. Okay. So different end conditions of columns, this is one condition. Second, different height of columns. Refer second diagram. One column is of height L1, another column of the same frame is of height L2. So in the same frame, if we have two columns with different heights, that frame will also qualify as sway type of portal frame. Third one, different I value of columns. I value is different. It means what? the cross-sectional dimensions of this column and this column both are different, B into D. Okay, so B by D, that is cross-sectional area of each column, is different. Even if both columns are of same height, end conditions are same, loading is also symmetric, but if columns are of different size, different cross-sectional area, that particular frame will be swayed type of portal frame. So third condition. Then fourth condition, internal hinge provided at beam column junction. Refer diagram number 4. Here beam column junction is here. So we see that an internal hinge has been provided here. So again, even if column heights are same, column cross-sectional areas are same, load is symmetric, and so on, and if in this case internal hinge is provided, again this type of frame will be known as sway type of portal frame. So fourth condition. Fifth condition is unbalanced horizontal force on the frame. If everything is same, only that loading is not symmetric. Geometrically frame is symmetric, I value of columns are same, end conditions are same, cross-sectional areas are same, horizontal load is unbalanced. If unbalanced horizontal force is there on the frame, this frame will qualify for being called as sway type of portal frame. So these are the 5 conditions. I'll revise in short quickly one by one. Different end conditions of columns, fixed and hinged end. Then different height of columns, L1, L2. Different I values of columns, that is cross-sectional areas are different for both the columns. Internal hinge provided at beam column junction like this, and unbalanced force horizontally on the frame like this. So these are the 5 conditions for any frame to be called as a sway type of portal frame. If any of the conditions are satisfied, that will be sway type of portal frame. Now we shall see what will be the additional equation of equilibrium for slope deflection method when we are solving sway type of portal frame. Okay, so let us see that equation. Now we shall see what is the additional equation of equilibrium for a sway type of portal frame when we are dealing this frame by slope deflection method. Okay, so again I have done some calculations. I'll just explain this in short. Before proceeding to this explanation, we need to understand some of the assumptions. So very first assumption, as we are going to say that the frame is going to sway, so sway, I am designating this particular term by delta. Okay, so sway will be always for columns only. So frame is going to sway only and only because of columns. So this delta is always positive for columns. Okay, this is first assumption. Second assumption, whatever the horizontal reaction or horizontal thrust is going to develop at the end of the columns, it is always assumed to act towards left, HA, HD. Okay, third assumption, delta for beams is 0. Always delta is 0 for beams. Why? Because if you see here, before the sway of the frame, there is some length of the beam, B to C. After the sway, it is going to shift. The beam is going to take a new position, let us say B dash and C dash. So will there be any change in length of the beam after the sway? No. Length BC is going to remain same as that of length B dash C dash. So there is no effect of delta here. So delta will be 0 for beam, but delta will be always positive for columns. Now these are the 3 assumptions. Okay. Now considering these 3 assumptions, we shall see how the equilibrium equation will be formed. So we are going to see shear equation. So this is the generalized loading. The unbalanced horizontal force on sway on frame is there, and because of this unbalanced horizontal load, frame is going to undergo sway. So I have taken free body diagram for column AB. Load P I have shown, it is acting at a distance of A from end B and small b from end A. HA is towards left as per the assumption. MAB and MBA, I have assumed these two moments induced because of sway as anti-clockwise. I have assumed them, okay, just for the ease of calculations. And for this particular free body diagram, I have taken summation of moment about B. So HA into L, clockwise moment, so positive. MAB, anti-clockwise, so negative. MBA, again anti-clockwise, so negative. P into A, minus, because it is anti-clockwise. So addition of all moments about end B is equal to 0. So HA I am going to get as MAB plus MBA plus P into A upon L. Next, I have taken free body diagram for column CD. There is no external loading on column CD, so I have just assumed again anti-clockwise moments because of sway on ends C as well as D, and assumed horizontal thrust on support D. So this free body diagram, for this I have taken summation of moment about C, and I have taken again HD. I have calculated HD, which comes to be MCD plus MDC totally divided by height of the column L. Now after this I have considered the complete frame, and for this complete frame I have applied summation fx is equal to 0, okay, for whole frame. So HA is towards left, so minus, HD again towards left, minus, P towards right, so plus. So minus HA minus HD plus P. This is the equation in horizontal direction. Summation fx is equal to 0. So I have solved it ahead. So HA plus HD minus P is equal to 0 is the equation, and I have just substituted back value of HA from here, value of HD from here, P as it is. So MAB plus MBA plus PA in divided by L plus MCD plus MDC totally divided by L minus P is equal to 0. So this is our additional equation of equilibrium, which is also known as shear equation. Okay, so when you are solving a sway type of portal frame using slope deflection method, you will need this additional equation of equilibrium. There are usual two equations of equilibrium which are which are for rotations. MBA plus MBC is equal to 0, which is on joint B if theta B is unknown, and if theta C is unknown, MCB plus MCD is equal to 0. So these are two equilibrium equations, two conditions of equilibrium, and this is the third additional equation of equilibrium, shear equation. So that's it, friends. This is my assumption and analysis for sway type of portal frame and how to frame or form shear equation for finding out the additional unknown delta. So if you have any difficulties, please write in the comment, and if you are new to this channel, do subscribe the channel. Thank you very much.